the completion of the previous video, and it's called A Better Idea 2, part 2. Now, we were interested in coding a byte or absorbing more than one bit of information within a bit. In order to do that, we should remember that if we divide a number into two parts, the difference between any two consecutive and say this is the higher value and this is the lower value. The difference that is coded between any two consecutive values for the higher value must be equal to the largest value that is coded for the lower part itself, or at least slightly more than that. This is always the requirement for it. So if we are coding from left to right, whatever value we add for the difference, one less than that is what will be the maximum we could add for the lower part. Now our objective is to absorb more than one bit within a bit. So if we have some kind of a string like this, so this value must lie between s by 2 and s by 4. And we have to code this in a value s. This value must lie between s by 4 and s by 8. This value must lie between s by 8 and s by 16. This value must lie between s by 16 and s by 32. This value must lie between s by 32 and s by 64, and so on. The original idea was not actually a bad one in view of the fact that instead of taking the ratios successive halves add up to 1, instead of taking the ratio between 0 and 1, we can take the ratio between, say, here would be half and here would be 1 by 4. Now note that the distance between these two is actually 1 by 4. So if we take the successive halves as the ratio there, we will have the sequence 1 by 8, 1 by 16, 1 by 32, 1 by 64, 1 by 128, and 1 by 256, and so on. But again, bring to your attention that now if you add up the sequence 1 by 8, 1 by 16, 1 by 32, if you add this GPC series, you will get the value close to 1 by 4, which is the distance there. Since we would like the value to lie between s by 4 and s by 2, this means even though this adds to s by 4, s by 4 must be added as a displacement initially. But we also have to take into account or bear in mind the fact that for the higher value, the difference between two successive values must be equal to the largest that is added for the lower one. In view of this fact, when we shift add a displacement of s by 4, s by 4 itself can be expressed as a ratio of successive halves like s by 8 plus s by 16 plus s by 32 plus s by 64 plus s by 2 power n s by 8 into, assuming n bits are being 8 into 2 power n minus 1. So actually the ratios that are actually associated from right to left, that means for the lowest one the ratio will be 1 by 8 into 2 power n minus 1. For this we add s by, so the ratios that we actually associate, the weights we associate from right to left for the higher byte will be s by 8 plus for the next bit, for the next left bit, since s by 4 must always be there, The ratio of s by this can be optional, but this can be always be added. So for the next one, the value should be s by 8 into 2 power n minus 2 plus s by 16 will be the ratio associated for the next. For the third one, it will be s by 8 into 2 power n minus 3 plus s by 32 and so on. So this is the sequence. In general, if we have to, I will just narrate the steps. First is we are given a desired quantity. We are given we have a given quantity and we have a desired quantity. First thing we do is ascertain all the facts concerning the desired quantity. Number one, facts, collect and organize, or collate and organize and relate. Relate and organize the facts. Then based on the facts, we come up with an idea. Next we test and try out that idea. See where it works and where it does not work. Why does it work, under what conditions it works, and why does it not work? How do we transform or change the idea so that the conditions become suitable for it to work, or how do we change our own perspective or point of view of looking at the problem so that we can see a solution there. Then next is we revise the idea, or improve and revise the idea and see if it works. If needed, what facts, additional facts we have ignored or neglected to take into account, that also we consider. And finally, we consider optimizing it. Once it works, we consider is it in its best and most optimal form, and then we optimize it. In the former case, note that we came up with all the ratios or the weights as follows: 1 by 8 into 2 power n minus 1 plus s by 8, 1 by 8 into 2 power n minus 2 plus s by 16 and so on. For the next byte, of course the interval will no longer be between half and this thing. The interval will be between 1 by 4 and 1 by 8. In place of s by 8 you will have s by 16, and in place of 1 by 4 you will have 1 by 8, the ratio. So the sequence of values there that will be involved will be 1 by 16, 1 by 32 and so on. And the smallest value that you will be adding will be s by 16 to the smallest of these, 1 by 16 into 2 power n minus 1 and so on. So this again, we must bear that in mind. So that a byte or at least n bits, more than one bit is accommodated between one bit, between two.